So this is a tap at a hotel that I stayed at in London in the UK, and I do not understand. We have a hot water tap on the left and we have a hot water tap on the right, and I am already done. Like, I'm out. I'm not doing this. This doesn't make sense to me until I see the sign that says the left tap operates the shower and the right tap operates the bath. So now I at least know if I will burn my head or my feet. The problem with this is that the tap is exactly where you expect it to be, and the sign is about 6 feet away on the side wall. Intuitively, every single one of you should look at that and say, that's just not good design. Those two things need to be close together. We talk about that in design terms as an issue of proximity, right? These things that are closely related need to be grouped together. Those instructions should all be right down where the tap is, so that when you're looking at the tap, you can see the instructions. There's probably lots of reasons. There's probably lots of good stories that go into why that's not the case. I think they probably just ordered the wrong shade of tile. If you take a look, it's a lighter brown tile, and it wouldn't fit there down in the other part properly because it's a different brown, and they weren't going to reorder all the tiles, whatever it was. But we look at that and we can intuitively say that's just not a good design. We need to group those closely related items, and it's a very simple and easy to understand design principle. Now, we're going to take that digital now, and what I'd like each of you to do is to take either your left hand or your right hand, you choose, and hold it up, and I'll wait, it's good. Hold it up and pretend you're grabbing onto a straw, a really tiny straw, not a big milkshake straw, like a little tiny cocktail straw. And what you're going to do is you're going to put that in front of your eye, and you're going to cover the other eye. You're all doing this very well so far. This is excellent. So take that straw, and you're going to look through it. And what you're going to do is cover the other eye or close it, whatever you need to do, and you're going to look at the screen. Okay? Now, you can just put your straws down for a second. You're going to look at the screen, and you're going to orient yourself to what's there. You're going to figure out what's on the screen, and then you're going to actually go through and complete the screen. So the screen is actually a form. And you're going to go through and you're going to do complete the form, okay? So straws up. No cheating. Don't look through the other, like make sure you cover that other eye. And here we go. While you're doing that, I will take a photo of you. Ooh, panorama. I see some of you are still working. That's totally fine. Suddenly, as soon as I say that every time, the straws all immediately go down, like you've been trained. Like, pencils down now. What did you notice when you went through this? What was the motion that you had to go through to fill out that form? A lot of left and right, yeah? A lot of left and right. There's a whole lot of things that happen here. And this design, or this form, was coded to be perfectly accessible from a technical perspective. This worked perfectly for screen reader users, people that were blind that relied on something like JAWS or VoiceOver or NVDA. It was completely accessible to them. They had no problems figuring it out. But when we started testing this with people with low vision, huge fail. Didn't work. And here's the reason why. When we take a look at this, we've got different pieces of information grouped together, and somebody that has low vision, right, that doesn't rely on a screen reader, that maybe is using magnification, they're looking at this screen, and when they are zoomed in and magnified on those questions, they can read the question. Well, when they get over to the answer, where are the questions? They're gone, completely gone. This is exactly the same thing as the tap and the instructions for the tap being 6 feet apart. Right? These need to be grouped together. They need to have better groupings. Right? But we don't have them. So when you're over here, and it's not that you can't find the questions and you can't connect the questions to the answers, but we've made it a lot harder. Right? Left and right. So we continue through this. We move to the next question. and we move to the next set of answers, and to the next set of answers to the left, and the answers on the right, and the questions on the left, and the answers on the right. And what is your next move? To the left, where you find the exact wrong call to action that you want people to take. But we've created a pattern of use, right? We've created this left, right, left, right, left, right, left, right. Go to the left, and there's the quit. We also have something called muscle memory. You probably got to the point where you were scrolling across with the straw, looking through, and you went over a certain amount, and you knew exactly how far to go over to get to those questions, to the answers, right? So that muscle memory kicks in, and that takes you directly to the previous button, our second least favorite call to action. Right? One other thing with this form, if you take a look at the 3 buttons, quit, previous, and next, all 3 of them in design terms have something we would say they have the same visual weight. They're roughly the same shape, the same size, the same color, the exact same visual characteristics. The only way to tell the difference between them is to read them. For somebody that's having difficulty reading because they have low vision, we've now made that job harder for them. That make sense? Right? There's 3 different things that we've done in here that make this very difficult for somebody with low vision to use. We've got this multiple column effect, right? We've got the 2 questions grouped together and 2 sets of answers grouped together, and another 2 questions and another 2 answers. We've got all of these things that we need to take into account. So proximity is very, very important. We've got this entire layout which is not optimized for somebody that has low vision. So we need to think about these kind of things. We can easily transform this, and most of you could probably redesign this in your head, and if I was to guess what's in your head, you would probably do something like this. We would turn that into a single vertical stack where we've got the right groupings. We've got a question with an answer, a question with an answer, a question with an answer, and a question with an answer. We have now got the right proximity so that when we're magnified and we're zoomed in, we're going to see the question and the answer together, because that's what we need. And what's the pattern of use for this? It's not going to be left, right, left, right, left, right. It's going to be straight down. We're going to put people directly onto that next button. So go ahead and do this now. Quick, straws up, fill out this form. Look, see, you're almost done. I can tell already. How much faster was that? We put people directly onto the thing that we want. And I'm not saying that every single form should have this layout, but it's something that I want you to consider. Like, is this a better layout? We know that it is for many reasons. This is also a layout that works not only just really well for people that have low vision, but it also works really well on this, that whole big supercomputer that you have in your pocket or your purse. Works really, really well. The things that we do for people with low vision actually make things really good for mobile as well. If you take a look at this magnified, we'll probably never get to the point where we completely eliminate that left to right scrolling, but we certainly do minimize it just by using this type of a layout. Really straightforward, place people right on the call to action that we want them to take, and then we've got some differentiation between those 3 calls to action. Visual weight is very different for those. So we call that the straw test. I'd like you to use that straw test. We use that for looking at wireframes. We use it for looking at mock-ups. We use it for looking at real interfaces. We do it all the time, and I want you to do it too. I want you to use that straw test. You will identify layout issues and just general design issues for people with low vision. All you're doing by looking through the straw is limiting your view. You're limiting your view. Somebody that can't see the entire screen that has low vision, if they're magnified, they're going to see maybe a quarter of the screen at once, a ninth of the screen at once, 1/16th, 1/25th, right? The more magnification they need to be able to see, the less of the screen they'll be able to see at once. So I want you to use that straw test as much as you can. And these are the kinds of things that I'm going to share with you that are all kind of these concepts of extreme design, okay? If you want to connect and hang out with me on Twitter, I'm Feather on Twitter. If you want to follow up, I've got a really kind of interesting thing that I'd like you to email me about here. Feel free to do so. We're creating a set of tools for designers to make better designs that are more accessible designs, and I'd love for you to email me about this if you're interested. A lot of this work that we're doing in with this idea of extreme design comes from this concept. Some of you may have seen this before if you've ever done statistics or biology or anything like that. This is like a binomial distribution or a standard distribution curve. And what it basically says is that in any population, when we take a look at any given characteristic, in this case, we're talking about somebody's height, right? There are very few people that are very, very short and very few people that are very, very tall, and then a whole lot of people that are somewhere in the middle, right? And the idea behind this is that when you take a look at any particular characteristic, you're going to have people that are at those extremes and a lot of people that are in the middle. Think of the same kind of thing for eyesight, right? Somebody that has no vision, somebody that has perfect vision, we're all probably, or most of us, the bulk of us are probably somewhere in between. That should kind of intuitively make sense. Now, a lot of this thinking for me was kind of sparked from watching this video several years ago. It was an ABC video called The Deep Dive, and it profiled the design process at IDEO. And I love this particular quote. If you go and search for that on YouTube, it should still be there. IDEO, The Deep Dive. They actually do a really interesting design exercise where they're designing a shopping cart, and not a shopping cart, an online shopping cart, but an actual physical shopping cart. And they look at all the different ways in which people use shopping carts. And so you have people that are in there and they're using the shopping cart and they're literally doing like a 10-minute tour trying to get everything done in 10 minutes. And you've got people that are shopping for 4 hours using their shopping cart. And they come up with some really interesting solutions depending on the type of person that you are. And that was just one kind of characteristic, right? They're looking at people that go shopping by themselves, people that go shopping with 3 or 4 or 5 other people, right? How many groceries are we actually buying? Is it a small amount? Is it a huge amount? And they're looking at designing for all those different scenarios. And I loved it because one of the things that they said is that when they look at these extremes, by examining these extreme ends of any particular phenomenon or characteristic, they end up creating better designs because looking at the extremes illuminates everything that's in between, right? If you're not at one extreme or the other, you're going to be somewhere in between. And if we can make things work really well for people that are at this extreme and at this extreme, we should cover most of the use cases in between. And I love that thinking in terms of how we approach accessibility and universal design. We think about that, and I'm going to ask you to do one more thing here. You may have heard this term before, the spectrum. If we talk about different characteristics, we've already done it here in terms of height, but if I asked you to put your hand up and draw a spectrum for me in the air, this is totally new. I want to see how you do with this. Draw a spectrum for me. Like you could put your hands up and you could just, I'm trying to avoid doing it to show you what to draw, right? Draw a spectrum. I'm seeing a whole lot of things. I'm seeing people doing, this is a lot of fun. I'm just gonna get the video camera out instead. But I'm seeing some of this. I'm seeing people drawing lines. I'm seeing some people, I actually saw one person, I think, draw a rainbow. People doing, which is totally fine, totally awesome. People doing this and showing different levels of how they kind of interpret a spectrum. And we usually think of it as this linear thing. And it's pretty natural. I kind of always thought about it this way as well. And in May, I saw this article from a woman with autism who was kind of trying to explain what having autism is like for her. And she put together this cartoon, and I've got the URL down there at the bottom, SA Teaches/Spectrum, if you're interested in it. It's an entire cartoon explanation of how she views her autism. And I love it because it's basically, we've had this idea for a long time that someone is not autistic or very autistic. And they're maybe somewhere in between there. And she has kind of come forth with this and said, the fact that we view it that way actually means that people have this idea that they can look at somebody and say, you're not autistic, or you're very autistic, or you're somewhere in the middle, just based on the way that somebody looks. And so she kind of came up with this explanation for it, that we see something about people and we put them into situations that they're maybe not comfortable with just because of the way that they look. And the way that they appear to us. And the rest of this cartoon is really, this was literally a huge thing for me to see this. She said, the truth is, someone who is neurodiverse in some areas of their brain will also be no different to your average person in other areas of their brain. And when I saw this, I thought, this is incredible. She views the spectrum like this, where here's your language skills, your motor skills, your perception, skills of perception, executive function, and your sensory filter. So she views herself as being something like this, really highly developed language skills, below average motor skills, very high perception skills, kind of average in terms of executive function, but very low in terms of her sensory filter. And I saw that and I thought, this is really kind of an incredible way of thinking about things. It is absolutely not linear. This is multidimensional, right? We're looking at all these different characteristics, and she picked these 5. There's really many, many more than that. But I looked at this as a brilliant model of understanding any type of ability. And so if you think of vision with the same kind of thing, we have peripheral vision, we have central vision or foveal vision, we have color vision, we have the ability to see in 3 dimensions because we have, if we close one eye, everything flattens out, right? We only get 3-dimensional stereo vision because we have both eyes functioning fully. And so there's all these different aspects of vision that we could apply the same type of model to. And I think this is really kind of fascinating. It blew my mind in terms of how I understood what autism was. Because I'll be honest, cognitive and neurodiversity type issues are probably the least well understood aspects of accessibility. And thinking about it on a spectrum is maybe not the way that we go if we think about it strictly linear. But looking at it this way really made a lot of sense to me. Now, I want you to think about this as we're talking about all the different examples that we look at for the rest of the afternoon. We often get feedback when we do workshops, so I'll do an accessibility workshop with a design team, and this is a very, very typical comment. All the stuff that you've taught us, yes, this makes things more accessible, but really, that's just a better design, right? Like you've improved the design. And so I started to think about this. Is there actually something where accessibility can be used to improve designs in general for everyone? We know from experience, we do a lot of accessibility testing and a lot of usability testing with and without people with disabilities. And every single time that we're working with people with disabilities on a usability study, they find the issues faster. They're more pronounced and easier to notice because something that might slow me down by 5 seconds or 2 seconds it's like a blip on the radar. But for someone with a disability, it might actually slow them down by 5 minutes. It becomes really obvious that, yeah, this is actually a much bigger deal than we thought it was. So we kind of have this hypothesis that doing usability testing with people with disabilities and making improvements that address all of those usability issues is going to make it better for everyone. And we've seen that, we see that play out in the physical world as well. So if this is true, we wanted to start looking at this and create a whole lot of things that help us design things that are more accessible, that are going to then help make them more usable to everyone. And so I want to share an example with you here. I want you to think of not being able to see a critical visual, like you have a design and there's something that's visual on there that is absolutely critical to the design. What do you do for somebody that can't see it? Now, this is one such example. We were working with a client, and this is the city of Ottawa, and what it's showing is a proposed boundary change. Now, this isn't the exact problem. We've kind of anonymized it a little bit. But the idea behind it is the visual on the client's project was that they were showing the differences between 2 boundaries on a map. Here's the original, and then here's the proposed boundary. And so this map is a very visual tool, and we were working with the team, and they were coming up with ideas. They're like, we don't know what to do for somebody that can't see this visual. How do we deal with this? If somebody can't see the polygons, they can't tell the difference. Right? They don't know what information they're even being presented with. And so we talked with them about it and said, well, what could you do? What's the wording that we use when we're talking about this in the accessibility world is a text equivalent, right? What's the text equivalent for somebody that can't see this? And so they started to come up with great ideas. They were saying things like, well, we could describe the current boundary. So that might go something like this in text. The current boundary for the city of Ottawa is bounded to the north by the Ottawa River, and it extends west to Arnprior by, oh, I've got to convert here, hang on, metric. It heads 22 miles to the west to Arnprior, at which point it heads, the boundary moves southwest for 5 miles until you hit highway, whatever it is, and then it turns and the boundary goes southeast for 32 miles or whatever it is. And they go through a text-based process to list and describe the boundary of the current boundary. And then they go through, and in order to make this useful, they have to say, here's the proposed boundary. The proposed boundary is this, and they would go through that and describe that all in text. A perfectly reasonable way of creating a text equivalent for what is being shown there visually. Some really smart person said, well, what about just describing the difference? What if it's not about, if we describe each one in text and say, here's the current boundary and here's the proposed boundary, somebody then has to figure out what the difference is, right? So why don't we have text that describes what the difference is? Perfect, absolutely. So they would say something like the difference in the boundary or the proposed boundary is now 5 miles further to the southeast and 12 miles further to the southwest. I did that wrong, but that's okay. The idea was, though, that they would describe those things. They would describe the delta, not just the individual boundaries. Somebody also said, hey, these are just latitude and longitude points, right? They're coordinates on a map. So why don't we give somebody the ability to pull out and provide a feed of all of that data, right? They could then take that, put it into any tool that they wanted to, and then they could figure out what, use a different, more accessible tool. It was like, great, all these things work. And I said to them, why is the map there? And they were like, well, because the design says to have a map on it. Like, no, but why is it there? And they're like, because we have maps on as many projects as we can. It's a thing that we do here. Like, no, stop. Why is it really there? Why does this information matter, right? What's the number one reason that people want to know whether or not they're inside the city or outside the city? I heard it already. Taxes, right? Are my taxes going to go down or up because of this proposed change, right? What's the service going to be like? If I'm now inside, does that mean I'm going to get better service? Are my taxes going to go up? What's going to happen? So we started talking with them, and they said, well, what's the real reason? We want people to know if this is going to impact them or not. And as soon as they said that, they came up with this idea, which was a completely different way of solving exactly the same problem. Instead of relying on a text equivalent for 2 polygons that were very visual, they came up with another method that was just there embedded in the page. Does this thing impact you? Right? Everybody has a postal code. Enter your postal code. Does it affect you or not? You get a yes/no answer right away. And we now have solved probably like 90% of the use cases of getting at the information that's in the map, right? Super simple, very straightforward. They still had to do some text-based information on there to describe the boundary change, but they made it much easier for people to consume the information that was in there for kind of like 90% of the people that were going to that map. So understanding the reason why we're doing something is really kind of an important piece of this. So what I want you to think about here is when you have a design and you're creating a design, what would happen if somebody can't see that thing? And I want you to pick the most critical visual on your page, in your design, and decide what's going to happen if somebody can't see that at all. What do we need to do? What's our text equivalent? They only came up with that idea by pressure, right? They knew they had to do something to provide a text equivalent, but they didn't know what. Iterated, came up with all these ideas, and they came up with a brilliant solution, right? That solves the problem and made this. And I think, would you agree that this is easier to use for everyone now? Right? Like, enter your postal code, done. We've done the straw test already. We limited our view of the screen. I want to do the same thing. This is a data table, and people everywhere around the world love data tables, mostly. One of the things that happens for people with low vision, if I were to ask you to do so, I'm not going to ask you to find a piece of data in here. But if you were looking through a straw at this data table, it becomes very difficult because when you have a limited view of the screen and you're magnified, right, and this is about 400% magnification, we're looking at a very small portion, it becomes very difficult to tell which column and which row am I in as you're trying to move through the data table. So we created a little thing for this to try and solve that problem, and really all it is a little thing that brings in the headers from the column header and the row header to just bring them in to say this cell has this data in it. So if you take a look, and this is really simply because we were thinking of that limited view of the screen. So this is what it looks like in real life. When you click on a cell or when you're hovering over a cell, there's a little call to action to pull those things in so that you can see, if you're magnified, what those things are. Now, we did this because we were trying to make this work better for people with disabilities, for people with low vision, because we know with that limited view of the screen, it's going to be very tough for them to consume this information. And almost every single person that we show this to says, but I want that, right? Like, this, I want that. We came up with some other different iterations, and that was a small table. But if you're thinking of pages and pages of data, right? And I know you guys never have tables that have more than 10 rows in it, but let's just say maybe somewhere there's rows and rows and rows and rows and rows of data. This becomes even more important for a table that is pages long. We did some other iterations of it as well, and if you want to go and check them out, examples.simplyaccessible.com/cell-headers, you can see some of the different iterations that we have there. We had one where we just pull in the entire header column or the entire header row, so that they were separated, because this might actually facilitate comparing across an entire row or an entire column, right? We had another version where we did it like on hover, and that was a failure, totally horrible. Basically, as soon as you moved the mouse, they would start sliding in, and then you would move the mouse to another one, and then they would reset, and another one would slide. It was not good. But we had to experiment with it to see what was there. We've got another experimental thing that we're playing around with, which is a video player. And ultimately what that video player does is it allows, instead of having the controls docked at the bottom for play, pause, fast forward, and all of that, instead of having it down there, that somebody could actually take those controls and drag them and drop them and put them anywhere in the interface that they want. So that for somebody with low vision, if they happen to be looking at this video, they could put those things, if you think of like a talking head video where there's like, there's some space off to the right-hand side or to the left-hand side, you could put the controls there and keep them very close to the person's face so that you could play and pause, really, really easily and conveniently while you still had their head right in the frame. And remember, somebody that's magnifying this isn't looking at the entire screen, right? They're looking at a small portion of the screen. So we've been playing around with ideas like that too. So this is a sneak peek of the tool that I was telling you about. So keep this to yourself. Don't tell anybody yet. This is the Walt Disney World homepage, and you can do transactions on there. There are things that we're doing all the time. We talked about doing the straw test. Well, we're going to put together this little tool for you. We've created a card, and it's basically, we want you to complete some kind of interaction. Whatever interaction you're looking to do it while looking through the hole in this card. Now, you could put a straw through there for real if you wanted to. The real version is going to have a smaller hole, because if the bigger that it is, the easier it is to see through. It's not as good of a simulation of what it's like to have low vision. But this, looking through this card, we think is a tool that designers will really like to just kind of test things out with. And you can hold the card a little bit farther away, bring it a little bit closer to simulate different levels of magnification. So what we want you to do is to go through a task and just think about your interface. What is the task that we're trying to do? We're trying to find a ticket for the Magic Kingdom, or we're looking for a hotel room at the resort from this date to this date, and go through that entire interaction while you're looking through the hole in the card. Okay? And that will illuminate a lot of these opportunities for creating improved layouts. I also want you to design for Dory, which is totally appropriate here. You guys remember Dory? Dory from Finding Nemo. Do you remember she's like the fish with the worst memory of all time, right? She's being chased by Nemo, and Nemo stops her. She says to Nemo, "I have seen that boat. I can take you to the boat. Let's go." And off she swims for like 5 seconds, and then she's like looking over her shoulder at Nemo and like, "Whoa, dude, why are you following me?" Because she's forgotten already. And she's like, "Oh yeah, the boat. Let's go to the boat." And then she forgets again and again and again and again. I want you to think about what that would be like to design for Dory. So if we have an interface, and you've probably seen a lot of these interfaces, thankfully this stuff is disappearing, but we've seen interfaces a lot of times where you would click on a field and the placeholder would disappear. And you forget what you're doing, right? Or assume you forget. What do you do? How much does it take for you to figure out what you're supposed to do, right? We keep going through this interface, and people are eliminating these kinds of interfaces now and are actually making things much better. I want you to think about what you would do in that scenario. So play the I forget card, right? Design for Dory. Choose something really, really important in the interface, and then assume that someone forgets it. What would you do differently? There's probably a lot of different things you would do. Many people with cognitive disabilities or different levels of ability in terms of their memory-related function, they would struggle to remember things. I'm 45, and I forget stuff all the time. I have 4 children. I don't forget them, but I forget things that happen because they're always at me with stuff, right? And I'll be in the middle of filling something out in an interface, and someone will ask me a question, and I'll come back, and I'm like, what was I doing? I don't even remember. So the memory-related issues are things that are going to impact everybody. So we might do something with this particular interface where instead of making that thing disappear or allowing it to disappear, we might do something like this where as soon as you type in there or as soon as you click in there, it doesn't disappear, it stays there, right? People were doing that kind of thing because they didn't want to have big form labels. They were putting them in as the placeholder because they didn't want form labels to take up extra space. We wanted to economize the space. But there's very easy and very simple things that we can do to change that now so that we allow people to forget. Let's assume that they're going to forget something, right? And make things better by providing those constant clues. Here's another example. And this is the way that placeholder is supposed to be used, theoretically, right? This is a date of birth field, and here's the format that I want the date in. I know for me, I still forget things like this all the time, and one of the limitations of the placeholder attribute is that as soon as you start typing, the placeholder disappears. So why don't we do something like this? If we assume people forget, maybe we'll do something like this so that we take it out of the placeholder and we just put it back up into the label so that people have that constant reminder. If you assume that people will forget, you will make solutions that help that scenario. Does that make sense? Pretty simple, not that difficult to do, but it's being mindful of those things. And so part of what these techniques are all about is giving you things to think about that you maybe hadn't considered in your design or making them more formal. This is another example where we do error messaging. We provide both global error messaging at the top, and and this is flattened so it's not interactive, everything is showing, excuse me. But we have a global set of messages at the top, and then we repeat them down below because when somebody is going through this page and they hear those error messages or they see those error messages, by the time they're actually filling in the form fields, they might forget what that error message was. So we repeat it down at a local level so that they get that little reminder. Your message up at the top might be 8 or 9 words long, and the version that's down below might be 3 or 4 words long. Just a simple reminder of something that they may have forgotten. This is also useful for people that have low vision, that wouldn't be able to see the entire screen at once, where they can see the global error messages and the local ones at the same time. I want you to think about designing for moving in one direction. This is an e-learning kind of quiz type thing. It's a little drag and drop, little drag and drop question and answer. If you take a look, here's what happens. So you click on one of these items at the bottom, and you're going to drag it and put it in the right place, so it's a matching type thing. Very, very typical in an e-learning scenario. So you'll see we'll put it right onto the target, and we'll drop it there. And if we take one and we drop it on just the words, it doesn't line up, and it just snaps back into place. Now, we were looking at this, we were evaluating an e-learning package, doing this kind of thing with somebody with disabilities, somebody that was using Dragon Naturally Speaking, so they had very little use of their hands. They were relying on voice recognition software. And what they were saying, in order to operate this interface, is they would say, click an argument, and that would do a click event on the words an argument, or click an object, it would click on that one. And then what they would do is that would basically move it to the middle of that object, and then it would say mouse drag up, and it would start to drag that object, no problem. It would take that draggable thing, mouse drag up, faster, faster, stop. As soon as they say stop, it's going to let go, right? If they try to drag it up and then over, they're going to say mouse drag up, and it'll start to drag it up, and then as soon as they say mouse drag left, to take it over to that spot where it should be dropped, mouse drag up, mouse drag up, mouse drag left. As soon as they started to do the left motion, it released it, and it started to highlight the text underneath it, right? The way that Dragon works is that when you initiate one event, it goes until that event stops, and initiating another event makes that first event end. If you were to design this so that people only had to move in one direction, and I know it seems silly in terms of how complicated could it be to move in more than one direction, but you can't, with Dragon Naturally Speaking, say mouse move top left. Like you can't do a diagonal. You have to go in one plane of direction only, right? So if I was to say to you, design this so that it works, so that you only need to move in one direction, right? What would you do? And believe it or not, some of these things, like that might be a complex action to move up and then over. How would you change this design? What would you do to it? Don't be shy. Go ahead. A drop down, stack the answers. So that I couldn't understand that at all. There was 7 people all at the same time. You could drag it to the label. There's lots of different solutions. Some of them would require radically different designs. One of them would require very minimal design change. And that would be this. What if we just make these things so that the entire thing is a valid hit target or a valid drop target? Right? You wouldn't think of that unless you put that constraint on it. Maybe you would. Maybe you would think about that up front. But if you play that one direction card, right, designed for moving in just one plane of motion at any given time, you would do something like this. Or you might come up with another solution that makes it really, really easy. I also want you to design for Andre or Fezzik. You might know him as Andre the Giant. You might know him as Fezzik from The Princess Bride. This is Andre the Giant. He was a professional wrestler who was 7 feet 4 inches tall and purported to be like 550 pounds. Big dude. This is his famous finishing move. I'm going to take 2 guys and put their noses in my armpits. You might remember him. You might remember Fezzik from The Princess Bride. If you look at him, he's a big dude. He's got a very large head compared to these 2 other kind of average-ish humans. I looked for a lot of things to kind of understand Andre's size, and I found a few things. This is Andre's hand on the left with somebody else's hand. I don't know what it was, and so I found it was great to depict scale, but it's all relative. I didn't know who that other person was and how big their hand was, so I couldn't figure out how big Andre's hands were. I also found this other photo of Andre holding a beer can, and this is a Canadian beer, but you guys might not. It's a metric beer, so you might not quite understand how big that is either. So I was looking for things like, what can I show you so that you understand the size of Andre's hands? These are both good, but they're both relative. They're not absolute. But I found this, and this I think will help you.
B5O.
Come on, you guys. It's only a little.
A hungry giant!
Hungry for a big honey taste.
Big taste, honeycomb, big taste.
Honeycomb fish! Yeah, yeah, yeah!
It's not small.
No, no, no! Honeycomb's got a big honey taste! Big, big crunch for a big, big bite!
Honeycomb cereal. Part of this big, complete breakfast.
Honeycomb's a big, big bite! Yeah!
Now, there were two pieces to that video that, I really wanted to share that all with you because that's awesome. But if you saw this part in there, you know that a honeycomb is roughly 1 inch wide, 1 inch across. And I tested this. I bought 75 boxes of honeycomb and I measured them all, also ate them all. I'm not training for any Ironmans currently, so that was all good to do. 1 inch across for a piece of honeycomb. And if you also saw in that video, you might have seen this, where Andre is actually holding a honeycomb. And now we know, relatively speaking, actually more accurately speaking, how big Andre's fingers are. Sorry, I know he's a little creepy. Let's do that. So we know that a honeycomb is about 1 inch across. Andre's, the pads of his fingers are about 1 inch across. Now, if you think of what that might mean for something like this, where the average human is using an Apple Watch, and what that actually means, average human finger pad is 10 to 14 millimeters wide, right? The Apple Watch, 42 millimeters high, and whatever the width is, 30, I think it's still 36 across. But if you take a look at this and you think about Andre's fingers, 1 inch, 25 millimeters wide, so that finger pad is actually pretty much gonna cover the entire thing. So if you take a look at this watch interface, and you see the Space Jam interface on the right, how is Andre gonna operate that? He's not, right? He's not. What would you do, if you think about this, what would you do to change that interface so that Andre could do it and so that he could use it? And most people are like, I'm gonna put like just an iPhone on his wrist and we'll go with that, right? Totally valid, totally valid. But if you needed to switch this interface so that Andre could operate it better, what would you do? Make it so that it's scrollable and there's only one thing tappable at a time, right? Everybody like instantaneously like, yep, got it, totally get it, right? I want you to think about that. Look at this interface here. If you take a look down in the bottom right-hand side, we've got these pagination controls. And I know you would never design anything like this, but somebody did, right? Those pagination controls, really, really small and zero tolerance, they basically touch one another, right? For somebody that has, and I don't have large fingers at all, but I would struggle with that on a touch screen, and you probably would too. What would you do to change that? You'd make them bigger. You'd probably put some buffer in between them, some space, give them some breathing room, right? I want you to think about that. Think about how easy it would be for Andre the Giant to use your interface, right? And if we say that Andre's, this is an extreme, right? Like not everybody's gonna have fingers as big as Andre. This is something I never thought I would really hear myself saying, but not everybody would have fingers as big as Andre. So what can you do to change your design? Look for those opportunities to make it easier for Andre to use. Instead of the little tiny buttons, we make them a little bit bigger, right? There's lots of things that we could do with this. So ask yourself that question: how easily could Andre the Giant use your site? We also want to do things like design for hands-free operation, and this is not just limited to the things that we're doing on the web. This is like in general, right? We design for hands-free operation. I want you to focus on the problem, not the solution. The concept of use voice recognition versus enable hands-free usage, they're very different, right? Use voice recognition is focusing on the technology, not on the problem that we're trying to solve. This is the dashboard in the Tesla, or the console in the Tesla, the very first one that came out. And I remember going to the Tesla store. It was in a mall in Toronto, the first ones that came to Canada. And I went in there and I sat down and the guy was trying to show me what to do. And we were looking at the navigation system. And he said, go ahead, give the navigation system a try. And I'm like, great, awesome. And he said, say the address that you want to go to. And so I said, he told me how to do it. I said, get directions to my address. And I gave it my home address. And it was great. It showed me all these options on the screen. It showed me 4 different routes to get there. And I said, this is awesome. I said, okay, choose one, because 1 was the one that I wanted to take. And he's like, what are you doing? Like, what do you mean, what am I doing? I'm telling it which one I want to take. He said, it doesn't work like that. I said, well, how does it work? He said, well, you use it to give it your address or where you want to go. And he says, and then you got to reach down and pick and touch the one that you want to go to. And I'm like, and I don't know if the Tesla is still like this. I hope it's not. But that's a very, very much a focus on the technology that we want to use, right? Like, I want to use voice recognition for this, or we need to use voice recognition, as opposed to enable hands-free usage, right? Enabling hands-free usage is the problem. It's not the solution. So I want you to be thinking about those things. I want you to think about this as well, something that we're calling the minimum viable interaction. There's a lot of minimum viable things out there. This is, I think, kind of an important piece of interaction design. And the minimum viable interaction is the smallest amount of information or functionality that somebody needs in order to complete an interaction. So ask these questions. What happens if somebody only reads the headings on your page? What happens if somebody only reads the links on your page? What happens if someone can only interact with form fields and they maybe can't click links for whatever reason? I don't know if that's maybe not realistic, but let's think about these things. What if we project an extreme onto your design problem? We talk about form field only interaction. This is a set of sliders that could be coded to be perfectly accessible to somebody that's using a screen reader. Totally no problem at all. We can go in here, we can tab through this interface, we can use the arrow keys, and as you're using the arrow keys, the value changes, and as that value changes, the new values could get read out to a screen reader user every 3 seconds or whatever seems appropriate for that interaction. But if we become a master chef and limit our tools, so if you've watched Master Chef, you know they basically get a picnic basket of stuff and they have to go and make something incredible with just the ingredients that are in there. Well, what if we limit our ingredients? If we limit our ingredients to say, hey, what happens if somebody is only able to interact with form fields? Using things like that widget, that slider, using that slider might be really difficult for somebody that's using voice recognition technology. It might be difficult for somebody that's operating a switch. I don't know if you've seen a switch before or how switch access works, but effectively what a switch can do is it will automatically scan the page looking for objects, and you will click. Some people that use switches don't have any use of their hands, and so they've got a switch embedded in the headrest, maybe on their wheelchair. Or it might be something where they have, and you may have seen people before that don't have the ability to open and close their hand. My grandfather had a stroke in the mid-1980s, and he was never able to open his left hand again. I mean, he had to physically pry it open to keep his fingers moving, but he couldn't actually open his hand or do anything to type with. He would have had to, if he had only the use of that hand, he would have been able to push on a button, but that would be about it, right? We all have these different levels of abilities. Well, for people with different levels of abilities, they may not be able to manipulate these sliders easily, but they might be very easily able to manipulate the text that's in a text box. So if we apply that extreme to it, hey, what would happen if somebody can only interact with form fields? We're not saying get away or completely get rid of things like sliders and custom widgets, but we can certainly support those things with basic widgets that work, right? The requirement here for this interface to work is that we're able to enter a number. It's not that we're able to use sliders, right? There's a difference between the two. It's kind of like use voice recognition versus enable hands-free usage. So we could easily do something like that. Another extreme, think of headings-only consumption. What if somebody is only able to use or to consume headings, or what can we do to provide for that? This is a flight search interface with lots of different flights that have been that have shown up in the search results. And you'll see here that we've got a sorting mechanism. So they're sorted by price by default, and we've got the price that shows up as part of the heading for each and every flight result that's there. When I switch and I say I want to sort by departure time, the departure time is buried down in the middle of the record, right? Or after the heading, it's in the first part of the record. And if I say I want to search and sort by shortest flight, the duration is actually buried even further in that record. If we express or project that extreme onto this, and we say, how is this going to work for someone that only uses headings, right? Can you make this interface easier to understand for someone that only consumes headings? That we're giving them that piece of information very quickly. And there's a good reason why. So as a screen reader user, if you've ever heard a screen reader before, people that use screen readers are often able to just go through the page listening to heading by heading by heading by heading. They'll press the H key or they'll have a keystroke that they use, and they will hear the first heading and they can decide, do I want to go further into that or not? If not, they go to the next heading, to the next heading, to the next heading, until they find what they think they're looking for. So why don't we do something like this? When we sort by departure time, why don't we make departure time part of the heading? So that now when somebody gets here, they go through this page heading by heading and they say $1,397 total cost, 10 a.m. departure time. If that's not part of my departure time that fits well for me, I move on to the next one and the next one and the next one until I find that. And somebody has very specifically expressed that they're interested in departure time because they clicked on that filter or that sorting mechanism, right? So let's bring that up and make it so that it's easier for them to get that information that they're after. Same thing with shortest trip. Sort by shortest trip, $1,501 total cost, 3 hour, 47-minute duration. We put that information in the heading to make it easier to consume. And if you think of that minimum viable interaction, what piece of information do people need to make a decision as to whether or not they want to move forward with that particular flight? If they've said duration, or if they've said departure time, we can give them that information much quicker by putting it in the heading. So I want you to think about that. Create the minimum viable interaction by providing the most valuable piece of information for decision making as early as possible. I also want you to think about transforming the digital to physical. And this one gets a little bit, I think this is fun. This is me and my dad. My dad's the one with the sideburns. This was the 1970s, as you can tell by the gorgeous lamp in the color and the color of our walls and the tile. This is me and my dad just the other day. So I'm down here. My wife and I have 4 children, and we brought them all down, and we brought my parents down as well to hang out for the week. And planning this trip and being on this trip with my dad, and I asked for permission to share these things, so it's not like me violating some trust of my parents or anything like that. I've got permission to talk about the experiences that I have working with my dad on computer-related stuff, because my dad's not a digital native, right? He was never a computer user until he retired, and now he spends a lot of time on his iPad and on his iPhone. We go through a lot of different things. We were getting prepared to come down here, and it was Wednesday night. I was at another conference Thursday, Friday, and then I came here Saturday. Wednesday night, I get a text from my dad that says, "Are you home?" I'm like, uh-oh. He comes over and basically interviewed me for about an hour to figure out the whole check-in process and what he needed to do to get onto the plane. And there's a whole lot that happens here. My dad actually, my dad is kind of a typical, older guy that was not a digital native, but that is now retired and has time to use computing devices. He's also had prostate cancer, and he underwent hormone therapy. And so he's had a lot of issues that have kind of come up because of that hormone therapy and the whole process, to the point where he doesn't have a whole lot of confidence in his abilities to use a computer and just be online. And he attributes part of it to actually going through that hormone therapy. And so he interviewed me for like a half an hour. I'm like, okay, when you get to and I had to think it all through. When you get to the airport in Ottawa, you're gonna be going to, you're gonna go to the US gate. So you're gonna wanna get let off at the 3rd floor. You're gonna go straight in, you're gonna head over to the right. You're gonna go through the gate, you're gonna drop off like we went through everything over and over again because he really needed to have that predictability of here's what's going to happen, right? He is very inexperienced with flying. My dad has flown 3 times in his entire life, right? 3 times, something that I take for granted. Sometimes I fly 3 times in a week, right, to 3 different places, and he's done 3 flights in his entire life. And he gets lost. He doesn't know what's going on. We went through all of that. We get here and we're trying to connect things up, and we put our reservation onto the My Disney Experience app. We're going through all of that. We're linking our park hopper passes. We're doing all of that stuff, and I'm able to get mine, of course, like no problem. Everything just works. But when my dad does it, it doesn't just work. And I'm like going back and forth with him, like, I can do this, you know, did you try this? Did you try this? Trying to be helpful. And then he sends me this text message, which, like, in big props to my dad for using emoji in his text messages. He's like, really, dude? Okay, this guy got everything straightened out. Both reservations and tickets are linked to my wristbands. He had to go into the main computer to fix it. So I no longer feel like an idiot because I couldn't do it. He felt stupid over and over and over again because he tried to connect that thing to his magic band 4 or 5 times, and it just never took. And he said, like, the guy had to go into the back end of the system, and maybe it's because our reservation was part of a convention or something, like who knows what. But something had to happen, and he couldn't do it. And his immediate reaction was to blame himself. When we run into a problem, and you're cruising a website or you're filling out something, you're like, you run into a problem, you're like, that developer doesn't know what they're doing, right? You're looking at the validation, you're like, what is that? That doesn't even, we're like on the opposite side of it, right? Because we're nerds. Well, my dad is not a nerd. He was like straight to blame himself every single time. He bought an MP3 player. And that MP3 player, my dad is that guy that goes and actually registers for the warranty on the site. And he's on the site and he's registering, and he tells me, you know, he's going through it, and this actually came up the very first time he was trying to book a flight, and he actually had me do the flight because he didn't want to sign up for anything, because the last time he tried to do something online, he went through this, and he got there and he was trying to register his MP3 player, and he said, I'm going through it, and I spent, you know, enough time on that form, and I thought everything was fine, and then it came back, I hit the button, I hit the button to go, and he said it came back, it was like a sea of red that was just staring at me. I'm like, what do you mean? He said, well, there was like an error message on every single field. And he said, why didn't they tell me on the page before? I'm like, my dad wants inline error messaging, and I had no idea that he would even understand the difference between these two things. He said, but I looked at those error messages and I felt stupid. I felt like it was me. We don't write error messages like this, but maybe we make people feel like that because we're nerds and they're not. What if we do something to help people level up? Can we use copy and design to help people feel successful right out of the gate, right off the bat? I know my dad doesn't feel successful. I see all kinds of things that he's working with where he hesitates on pretty much everything, right? He's on the app, he's like, do I touch that one or do I touch that one? He doesn't know. It wasn't obvious from the design. And I think there's some things that we can do that actually might help. One of the things that I'm thinking about with this is the transforming the physical to the digital, or the digital to the physical. You've seen things like this before, right? Passwords where you have like a strength indicator beside it. This is something that we came up with. I don't know if you've seen them before, but we've got a Philips Hue light. And it's basically this big lamp that you can put anywhere in the house. And you can have all kinds of these Philips Wi-Fi connected lights. And so we created this little thing that might help ease what's going on or might give people better clues as to what's happening. So if you take a look, as we type in the password field, we'll get different strength indicators so that it's like a weak password, or it's a fair password, or it's a strong password, or it's a very strong password. I have this feeling that taking something for non-digital natives, taking things and putting them into kind of that digital world and making them so that they're a little bit more physical and they manifest themselves in different ways might actually be something that's really good to help people level up, so they get different kinds of feedback that is maybe more in tune with the kinds of things that they're into and the kinds of things that they're after, and maybe the world that they expect. 50 years from now, maybe this won't matter, right? Everybody's going to be a digital native. We'll have these lights that are all like embedded in our heads-up displays that are embedded into our corneas and everything like that. It'll be a very different world then. But until that happens, we can do things that make things better for all kinds of different people. So what I really want you to do, and I hope you've taken away from this, is all these different methods to project some type of an extreme, right? Project that onto a design problem, solve that problem, and then make that thing better for everybody, including people with disabilities and without. Thank you very much.